Hey class, this is a short video on how to solve both momentum and impulse questions when it comes to this unit we're talking about in physics. The first question says, what is the momentum of a 1,347 kilogram car traveling at 47.3 meters per second? Okay, the first step when you're solving these questions is to identify your formula for what you're solving for. What are you solving for? What is the momentum? So, question mark, P. Remember, P, as we learned in our notes, stands for momentum. What is the formula for momentum? Well, we saw that as well. P equals mass times velocity. So we simply plug these numbers that we're given into our formula. P is what we're solving for again. P equals mass, 1,347, times velocity, 47.3 meters per second. Pull out your handy dandy calculator that you should have by now. 1,347 times 47.3 gives us a big number, 63713.1. So 63,713.1. With momentum, we don't even change the unit, we keep both. So 63,713.1 kilograms meters per second. All right, impulse questions. If it takes 13.5 seconds to stop the car mentioned above, using a force of 2,210 newtons, what is the impulse? Now remember, momentum is how much stuff you have moving at whatever speed. Impulse is how much force it takes to stop that particular object. So what are we solving for? What is the impulse? Question mark I for short. What's the formula for impulse? Well, it's impulse. You have to have time and you have to have force. So impulse equals force times your change in time. For this situation, we start at 0, we end at 13.5. It's going to be the same. So come back over here. I equals our force, which is 2210, times our change in time. Well, to find the change in time, you take the time final minus the time initial. So this is where we ended. This is what we started at. 13.5 minus 0 is still 13.5. Grab that calculator again. 2210 times 13.5 is still a big number, not quite as big as our momentum. 29,835. So 29,835. Again, we don't get rid of our units, we keep them. So kilograms per meters per second is for momentum. For impulse, it's Newton seconds. And there we have it. Now, they can ask us a multitude of questions based upon this, but we're still going to be using the same formulas and the same techniques as we have all year. Identify the unknown, look at what you have, solve for the unknown. Next video, I'm going to show you a few examples about how momentum is always conserved.